Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today my presentation is on detection of light in chocolate using Fourier transform infrared. I am Nur Fatiha Nabila binti Rosli from MSc of Food Science and Technology. The outline of my presentation is first for introduction, then I will proceed to literature review. Next is research methodology, and last will be conclusion. For introduction, the research background. Porcine has been used widely in food industry due to its abundant source, cheap price, and multifunctional properties. Porcine can be as a food additive or the main ingredient in a food. It has been the source of inexpensive gelatin or emulsifier in gummy candies, ice cream, and chocolates. However, by reasons of dietary religious restrictions such as halal and kosher and allergy, the presence of porcine or porcine DNA in food are not welcome. Food manufacturers are obligated to clearly label the ingredients in food products. Nevertheless, cases of food fraud happen because of deceptive labeling or scheme substitution. Lard is a derivative of porcine. It comes from adipose tissue of pig. Since pig comprises high number of adipose tissue, so it holds a very high amount of fat. In most baking industry, lard is preferable as a shortening gelatin or emulsifier as it is very cheap and gives a richer taste to the food. A study by Sudrot al. and later confirmed by Cheong al. revealed that the commercial emulsifier available, specifically monoacid or known as MAG and diacyl DAG glycerols, which bears the code E471, are potentially derived from hydrogenated lard. E471 has been commonly used in chocolates and its products, as most food manufacturers did not clearly state the source of MAG-DAG. The halal and kosher status of this emulsifier is doubtful. Fourier transform infrared is based on vibrational spectroscopic technique that is used broadly for analysis of food products to detect adulteration. The preference to use FTIR for food analysis is because of its accuracy, non-destructive to samples, environmental friendly, and fast. FTIR coupled with principal component analysis can measure and characterize the presence of light in food products such as cakes, chocolate, and biscuit. The main concept in studying light in chocolate is to have a semi-quantitative method to measure the presence of light based on the percentage of light in it. For the problem statement, currently the methods used for detection of light in food products are DNA analysis. There is using polymerase chain reaction and real-time PCR and immunoassay analysis. Although these methods give high accuracy result, it is time-consuming, requires expensive instrument, and have complicated sample preparation steps. The high number of food fraud cases that is related to adulteration of food ingredients are growing around the world. The authenticity of food is a vital issue, especially for consumers for reasons such as the legal conformity, religious reason, especially for halal and kosher issues, economic reasons, for right foods for the right price, guarantee of a constant, well-defined quality, and the use of safe ingredients, meaning there's no hazardous substitutes. There are several approaches that can detect the level of adulterant in foods. The first can be by assuming the ratio of chemical constituents in the food are constant, so that any adulterant added to the food can be detected, because there will be a change in the ratio. However, the most ideal approach to detect adulterant will be the one with low cost testing, fast, easy to operate, accurate and reliable. The objective of this study are to detect the presence of light in adulterated chocolate samples and commercially available chocolates. Next is to characterize the profile of light within the mid-infrared spectrum. The significance of study are food fraud is a paramount issue for consumers, especially for food adulterated with pork and its derivatives. The case of Cadbury chocolate in 2014 has shook Muslim consumers as it is a very sensitive issue. The company has lost $37 million in USD in sales globally in only 10 days because of the controversy, which shows how serious this issue is for Muslims all around the world. By conducting this study, a fast and accurate device to detect adulterant of light in food samples can be developed. The reason behind using FTIR is because FTIR has a fingerprint technique that can differentiate between light and fats that comes from other animal or plants. For scope and limitation of study, this study involves the detection of light in adulterated chocolate samples on a different percentage and commercially available chocolate samples. Although it is preferable to study more of food samples, but due to cost and time limitation, this project focuses on the detection of 4 chocolate samples only. Next is the literature review. First is pork and its derivative. According to Food and Agriculture Organization of the United Nations, pork covers for about 36% of the world meat intake, making it the most broadly consumed meat. Pork derivatives are any food ingredients that comes from or derived from pigs. The common pork derivatives are lard, which comes from pig fats, and gelatin, made from pig's bone and skin. Lard is made through rendering process, which is a process that utilizes waste animal tissue. Although rendering process is beneficial and efficient in terms of utilizing animal carcass, the rendering process is done through heat application, which causes the protein in pig's adipose tissue to denature and reduces them permeable to fat and water. The quality of lard produced is based on the species of pigs and processing methods. When the rendering process done properly, the lard produced will be odorless and tasteless. Commonly, lard is used as shortening, butter, and cooking fat. In baking, lard is preferable as it can give a flaky texture to the pastries. In addition to that, lard can give higher degree for tenderization compared to butter. Furthermore, lard can prevent staling by retarding the starch gelatinization as a result of starch coating. Since lard and vegetable fats has the same physiochemical properties, a lot of manufacturers have been caught adulterating vegetable oils with lard to maximize profit, as lard is the most inexpensive animal fat. Study by Marika al. verifies lard can be blended effectively with other vegetable oils, so butter, margarine, shortening, and other food oils can be produced. According to Chayman al., some countries opt for the combination of lard and vegetable oils to produce different types of shortening. When used for frying, lard can enhance the flavor of the fried food. Because of the many benefits of lard in food industry, a lot of research have been studying its characteristic, alternative formulation, and adulteration detection tests. Halal authenticity. The word halal comes from Arabic, which means permitted or allowed. The halal terms have been laid out in the Holy Quran. He has only forbidden to you that animals, blood, the flesh of swine, and that which has been dedicated to other than Allah. But whoever is forced by necessity, neither desiring it nor transgressing its limit. There is no sin upon him. Indeed, Allah is forgiving and merciful. This is Quran, Surah number 2, verse 173. Halal is used involving food and other goods, which means that it is permitted to eat or use by Muslims. The opposite of halal is haram, which carries the meaning dark. Type of foods that are haram can be classified into four major types. There are pigs and its derivative, carrion, alcohol and its derivatives, and derivatives of blood or part of human. Due to technological advancement in the science and technology, especially in the food processing industry, fraud and adulteration may happen. Food adulteration is when a food ingredient is replaced with non-compliant ingredients, either accidentally or intentionally, to reduce production costs, to maximize the profits, or other malevolent purposes. In the past few years, the controversies of food products adulterated with lard has growing. Food products adulterated with pork or lard is a major concern for Muslims and Jews, as they are strictly prohibited to consume pigs and its derivatives. With the growing availability of food available in markets, the authenticity of halal food has increased the concern amongst Muslim consumers all over the world. As the increasing number of food fraud cases happen, consumers demand for transparency in the farm-to-fork process. To provide the transparency to consumers, the development of the adulterant detection is important. Certain studies have been developed to test the halal authenticity of food, such as in cake flour, chocolate and chocolate products, biscuits, formulation, butter, and cocoa butter. The most important method in halal authentication is the harmonization between science and Islamic law as to keep from fraud. The food technology field has advanced rapidly and getting more complex. More and more innovation of food ingredient calls for increasing demand of halal authentication method that is reliable. The responsibility for halal authentication does not bear on expertise from the Islamic law only, but as well as other related fields, for instance, food science and technology, material science, and chemistry. Due to the advancement of the food processing, halal authentication could not be dependent exclusively on observation and documentation anymore. It requires advanced analytical technology. The analytical methods for detection of light. Analytical methods used for detection of light are based on the differences in the nature and in the composition of components present in the light and in food. The methods depend on physical, chemical constant, or non-chemical and biological measures. The popular analytical method is Fourier transform infrared and chromatography-based techniques. FTIR is based on infrared vibrational spectroscopy. The region suitable for food authentication and detection is the mid-infrared region. FTIR measures the absorbance of IR radiation of dipole bonds in functional group of molecule. The absorption of the radiation excites the electrons in the bonds to a higher state of vibration. The reason FTIR is the most popular technique is because it is accurate, rapid, and reliable. The wavelength used for the detection studies is 4000 to 400 cm power of -1. This region can prove the presence of molecular bond that presents in light. In comparison to this specific instrument, FTIR spectroscopy have higher sensitivity, excellent wave number reproducibility, and accuracy, and allows higher energy throughput, which can improve the speed of spectral acquisition. Although the infrared spectra of light is almost similar to the spectra of animal fats and vegetable oils, because of the existence of triglycerides in the fats and oil, the fingerprint technique that FTIR offers can differentiate the spectra. The fingerprint technique has the advantage that there are no two compounds that have the same spectra in terms of frequency and intensity of peaks and shoulders. This technique in FTIR allows the extraction of differences between light and animal fats and vegetable oils, which permits one to make a preliminary differentiation of light. For the analysis of light in chocolate and chocolate products, Sheyman et al. Used region 4000 to 650 with resolution 4 cm-1. The research group used partial least square regression to analyze the data. For the PLS equation, the assessment of accuracy was based on the smallest standard error and the coefficient of determination. And the pictures here show the example of the FTIR spectra between pure cocoa butter and pure light. From the spectra, the functional groups present in the food sample and light can be differentiated. The C-O group of triglyceride is found at 1746 wavelength. The 1C stretching usually shows weak absorption and can be found at between 1667 to 1640. The region between 1400 to 1000 are very hard to assign the functional groups. For chromatography-based techniques, there are various methods of chromatography-based techniques that have been employed in food detection, such as high-performance liquid chromatography, gas chromatography, and liquid chromatography mass spectrometry. These techniques are reliable for the separation and quantitative analysis of major and minor components with highly similar chemical structures in complex food. Due to this advantage, this technique has been employed in food adulterant detection. The disadvantage of this technique is because it requires a laborious sample preparation step. HPLC is used for analytical and preparative separation of compounds in a complex mixture of diverse origin. Its main advantages are the sample components that are not readily volatilized can be separated easily with HPLC, which make HPLC a favorable option for detection of contaminants or adulterants in food. GC is suitable for analysis of volatile compounds such as fatty acids, alcohol, esters, and others. Gas chromatography with flame ionization detection (FID) can be used to detect the adulteration for fats and oil. GC-FID technique works by comparing the retention time and peak areas of the fatty acids, which have been derivatized into fatty acids metal esters or FAME. They are not according to standards. The structure and composition of the FAMEs can be used as an indicator to track the source of the fatty acids. For our research methodology, this is the flowchart of activity for this project. First, we will the extraction of fats from chocolates, and at the same time is the preparation of pure light. Next is fats from obtained from chocolate will be spiked with pure light. Then the sample will analyze with FTIR, and the FTIR spectra will be analyzed using principal component analysis. For extraction of fats from chocolate, 12 samples of chocolates from the local market are purchased. The chocolate samples are then ground using mortar and pestle. The grounded samples are labeled to avoid any mix-up. The grounded chocolate samples are put into tissue using a forceps into a long mold. The tissue paper will be inserted into the thimble into the siphon. Then both the thimble and siphon will be placed in the circular apparatus for the extraction into the water bath. A conical flask at the bottom of the apparatus will collect the oils for about 8 hours. For preparation of pure lard, blood sample will be prepared from the process of adipose tissue, which will be purchased. The adipose tissue is cut into small pieces to optimize the fats extraction and put into small bowl. The bowl will be placed in the oven at 90 to 114 degrees Celsius for about an hour. The lard collected will be placed into a beaker, and hydrosodium sulfate will be added into the beaker to absorb water from the lard. For the standard samples, for sample preparation, the standard sample will be the pure cocoa butter and then pure lard, and then there will be a cocoa butter that will be spiked with lard with 0 to 15% range with intervals of 0.5 gram. All mixing will be prepared on a weight basis to calculate the exact actual percentage of the added fats. The spiked samples, 12 fats from chocolates and the pure lard, will be analyzed using FTIR. For FTIR analysis, the samples are placed in contact with the ATR element at room temperature. FTIR spectra will be collected under the region 4000 to 650 with resolution 4 cm. All spectra are going to be ratioed against a background air spectrum and stored as absorbance values at each data point. All samples will be scanned in duplicate. Next is the flowchart for the principal component analysis. From the FTIR spectra, we will identify the independent and dependent variables and then transform the data into matrices, then calculate the mean and standard deviation of the data, find the covariance matrix, find and eigenvectors and eigenvalue, and then from that we can plot the scree plot and Parkes plot and also loadings and score plot, and we can find the outliers. Finally, we can find the information of the relationship between the sample and parameters. Lastly, the conclusion. This study is to identify the lard in chocolate samples commercially available with reference to spiked chocolate samples. As mentioned above, the first objective is to detect the presence of lard in the adulterated chocolate samples and commercially available chocolates. This objective will be achieved by analyzing the samples under FTIR spectrophotometer. The samples in this study are fats from 12 chocolate samples, pure lard, pure cocoa butter, and cocoa butter spiked with lard at 0 to 15% range. The outcome from this objective is a set of complex spectrum which proves the presence of lard in the samples by locating the functional groups that are present in lard. Next, the characterization of lard using principal component analysis is the second objective of this study. To achieve this objective, a method named principal component analysis will be executed via MATLAB software. PCA will simplify complex data obtained from the FTIR spectra. By using PCA, it is possible to locate the region in the spectra that is constant, so that the future research can search the region only to locate the lard. That's all. Thank you.